Hey there, science fans. Welcome back to another exciting episode where we unravel the mysteries of science. Today, we're diving into the fascinating world of colligative properties. These are unique properties that emerge when we mix substances together. These properties sound complicated, but they're actually pretty simple to grasp once you get the hang of it. Colligative properties are all about how a solvent behaves when we add a solute to it, forming a solution. It's like a magical transformation. The coolest part? These properties depend solely on the number of solute particles in the solution, not on the solute's identity. So it doesn't matter what the solute is. Think of it like this. Imagine a party. The more people you invite, the more lively it gets. The number of people at the party affects the vibe, right? It's the same with solute particles in a solution. It doesn't matter if they're wearing hats or sunglasses. More people mean a livelier party. Similarly, more solute particles mean a greater effect on the solvent. That's colligative properties in a nutshell. Simple yet fascinating, right? More solute particles mean a bigger change in solvent behavior. This can affect things like boiling point, freezing point, and even vapor pressure. Let's explore some of these properties in action. Stay tuned as we dive deeper into the science behind colligative properties and see them come to life. Ever notice that adding salt to water makes it boil at a higher temperature? That's boiling point elevation, one of our cool colligative properties in action. When we add solute particles like salt to a solvent like water, the solute particles interfere with the solvent molecule's ability to escape into the gas phase. This means we need more heat energy to get the solution boiling. The more solute particles we add, the higher the boiling point climbs. Now, let's talk about the flip side freezing point depression. This property is all about how adding a solute lowers the freezing point of a solvent. Picture this. You're making homemade ice cream and add salt to the ice surrounding your ice cream mixture. The salt dissolves in the ice, creating a salt solution that has a lower freezing point than pure water. This allows the ice cream to freeze at a lower temperature, making it nice and solid. Cool, right? Section 4. Vapor pressure lowering, keeping it under pressure. In this section we will explore the fascinating concept of vapor pressure and how it can be manipulated. Vapor pressure is a measure of how easily a liquid evaporates. It is an important property in many scientific and industrial processes. When we add a solute to a solvent, we lower the vapor pressure of the solution. This phenomenon is crucial in understanding how solutions behave under different conditions. Think of it like this. Imagine a crowded room with a single exit. The more people in the room, the more difficult it becomes for someone to reach the exit and leave. The more people in the room, the harder it is for someone to reach the exit and leave. This analogy helps us understand how solute particles affect the movement of solvent molecules. Similarly, the more solute particles in a solution, the harder it is for solvent molecules to escape into the vapor phase, lowering the vapor pressure. This concept is fundamental in fields such as chemistry and chemical engineering, where controlling vapor pressure is often necessary for various applications. Section 5. Osmotic pressure, nature's balancing act. Osmosis is the movement of solvent molecules across a semi-permeable membrane from a region of high solvent concentration to a region of lower solvent concentration. Osmotic pressure is the pressure we need to apply to stop this solvent movement. In simpler terms, it's the pressure needed to maintain equilibrium between two solutions of different concentrations separated by a semi-permeable membrane. Section 6. Colligative properties in everyday life, from kitchen to clinic. Colligative properties are fascinating aspects of chemistry that influence our daily lives in ways we might not even realize. Colligative properties are more than just cool science concepts. They're at work all around us. These properties depend on the number of particles in a solution, not the type of particles, making them universally applicable. We already saw how they come into play in cooking, like when we add salt to water for boiling pasta or making ice cream. The salt lowers the freezing point of water, allowing us to make delicious, creamy ice cream at home. But did you know that colligative properties are crucial in medicine too? These properties help us understand how to create solutions that are safe and effective for medical treatments. For instance, hospitals use saline solutions, which are carefully prepared solutions with specific osmotic pressures to hydrate patients. These solutions must match the osmotic pressure of bodily fluids to prevent cell damage. Understanding colligative properties helps us explain and utilize these phenomena in countless applications. From preserving food to developing new medications, these principles are foundational in both everyday tasks and advanced scientific research. So keep exploring, keep learning, and stay curious. The world of science is vast and full of wonders, and colligative properties are just one of the many fascinating topics waiting to be discovered.